I'm really excited to have joining us today, Gabriel Steinhardt. He's the founder of Blackblot and the recognized international product management expert, author, and lecturer. He has published 2 books on product management and 1 on product pricing, and his Blackblot Product Manager's Toolkit aims to provide a practical, consistent, and holistic approach to product management and helps both PMs and organizations develop clear and consistent practices. We're really excited to have him joining us today, and welcome, Gabriel.
Thank you all for joining in today, and it's a pleasure for me to be here with you. My name is Gabriel Steinhardt, and this presentation is titled Algorithmic Feature Prioritization. Following this session, you will be able to describe the importance and implications of product feature prioritization, realize the pros and cons of scale-based prioritization and scoring methods. Sometimes they're also called sorting methods, and apply Blackblot's Boolean-based algorithmic product feature prioritization model. So before we start sorting product features, let's understand what are product features. So I think everybody knows what Gore Tex is. Gore Tex is a waterproof, breathable fabric invented in 1969 by Bill and Bob Gore, a father and son combination. They're both chemical engineers, and they issued a strong patent on the Gore Tex fabric, and the Gore family became billionaires. Now, Gore Tex is a technology. It's a layered fabric that repels liquid water trying to come in from one side while allowing water vapor, something like sweat, to pass through from the other side. It is a fabric that's designed to be lightweight, waterproof, and breathable. Now, what we see over here is a Nike shoe constructed with Gore Tex fabric. You can see the red circle over here that indicates that this shoe was constructed with Gore Tex. And therefore, this shoe has the feature of being waterproof and breathable. Now, in order for us to fully understand what it means, a product feature, then let's go to the PMTK glossary and see what it means. A product feature is a product's functional capability that satisfies a specific customer need. And therefore, the capability which the product has is its feature. And a product feature set is the sum of all product features that represents the reality of what a product can do, which is the sum of all the capabilities that the product has. Now, technology is the enabler of a feature. Technology creates and enables a feature. So here's some simplified examples. The Swiss Army knife has a feature of cutting, and the technology used is a metal blade. The Nike shoe has the feature, the capability of being water resistant. Technology is Gore Tex. Navigation software has the ability to present different routes and allow us to plan and choose the route that we want to take in order to reach our destination. GPS is the technology. MS Outlook, which I know everybody knows, it's a messaging email application made by Microsoft. The feature is messaging, and all those protocols, SMTP, IMAP, and so forth, are the technology which enables the feature of messaging. So here we have is a simplified product feature set. And one feature is that it's obviously waterproof and breathable. And let's assume that there's some kind of construction in the heel or the sole that makes it shock absorbing. So it's shock absorbing, and the materials are sturdy, so it is wear resistance. If we take another example of a feature set, then navigation software has the ability to help us with route planning, suggest several routes and you choose one. Live tracking, which means that other people can follow us along the path where we're progressing towards our destination. And weather forecasting information, so we can make a more informed decision on a particular route or path. Now, the question is, why do we need to select and prioritize these product features? Why can't we have it all? Or in another sense, what is the problem of having it all? Really, there's a question over here what is the importance and what are the implications of doing product feature prioritization? So first, we need to realize, of course, that the product is a solution to the market problem. The product, by merit of its feature set, is the solution to the market problem, which obviously customers want to solve. So this obviously means that any given product feature set have a direct bearing on the product's chances of achieving marketplace success. So selecting the right feature set is important and can lead to having the right solution to the market problem. Another thing is that the selected feature set immediately impacts the development effort and the subsequent marketing and operational activities. And that every feature has to be developed, tested, fixed, documented, marketed, sold, supported, and then possibly terminated. So there's immense implications for every feature in terms of the effort, the work, the cost, and the schedule. This means that we need to optimize the feature set. It is critical to select the best features and optimize the feature set to fit the market needs to get that optimal solution, subject to the budget and the scheduling constraints. Now, in order to do that, we need to engage in something which is called the product feature selection process. And this product feature selection process is comprised of 3 stages or phases. So the first one is to identify redundant, extra, superfluous, or missing features. This is done through something called traceability, and it's out of scope for this particular presentation, so we're going to skip it. Then once we have the feature set, we can arrange those features in groups and release the product in stages into the market. A more accurate way of describing it is that we're going to release the functionality into the market in steps progressively. So this is, again, is out of scope for this presentation, how to do roadmaps and versions. But lastly, we're going to analyze and prioritize the features, and sometimes we're going to move features between versions or decide, depending on how we launch products, which features are going to come first, are going to be included. So let's discuss the product feature prioritization process, or what's happening now in the market. The most commonly used and arguably the most biased and ineffectual way of prioritizing product features is what's called a simple, unstructured debate. Usually have the product stakeholders, mostly people from product management and product development, perhaps people from sales, maybe 1 or 2 executives. They all convene for a series of periodical prioritization meetings. And in those meetings, they argue their feature preferences, their personal feature preferences, and they negotiate feature prioritizations. The unstructured debates are notoriously lengthy without a lot of progress being made. Often there's 1 or 2 meetings near some kind of a critical milestone, like a product launch or some kind of release to the customer, whatever it is, in which everybody convenes to these hastily enforced meetings, and very quickly resolutions are made and prioritizations are decided upon. Sometimes these meetings can be very long and rife with a lot of conflict and internal bickering. The bickering could be around areas of ownership, final decision-making, which prioritization criteria to use, which scores to assign to each criteria. So what they do is they move to a more structured debate. This is called a semi-structured debate, by introducing into discussion some kind of a market-related consideration, some kind of a deadline, technological trends that you need to match, a competitor has launched a product, economic, political, it could be something like that. And they focus on it. But it's all very vague and subjective, and it doesn't really help you do prioritization on a larger scale. So in order to bring more structure into the discussion, they take a look at something which is called ranking and scoring methods. And sometimes these are called, again, sorting methods. So here's some of the more popular ranking and scoring methods: Moscow, rice, ice, weighted, short, job first, and so forth. The thing about these scoring and ranking methods is that there's many of them. It's really going to Antarctica, and everywhere you turn, there's a penguin standing there. There's actually, somebody did a survey and they found that at the moment, more than 170 different product feature scoring and ranking methods available to choose from. So everywhere you go, there's a new one. Now, in aggregate, talking about these 170 different types of scoring and ranking methods, there are challenges in using them. And some of them are too abstract, these things called impact and reach. You have to define things in a more accurate way in order to use them. And that is a bit of a challenge. Some of the meetings are centered on trying to explain what is impact and what is reach and how to quantify it and how to score it. Difficult to reach agreement on many things which are vague. It's time consuming to try to parse different types of criteria. These methods don't work well with ad hoc requests. For example, an executive comes and says, I want to add this feature, or a customer says, I'll pay you to add this feature. A lot of the criteria and these methods are very high level. They're debatable, subjective, and you often don't have enough information. Many of these ranking methods use a scale, and the significant downside of using scale-based prioritization is that the participants quickly gravitate to repeatedly selecting the intermediate values of the scale. So if you give them 1 to 10, they will focus on a 7. If you give them 1 to 5, they will gravitate towards the 3. If you use a qualitative scale, then they will gravitate to the intermediate value. If you give them high, medium, low, they're going to go for the medium predominantly most of the time. Now, some of these ranking and scoring methods use something called weighted scores. Weighted scoring grants certain variables more weight, more impact in the calculation of a final score that determines the ranking. For example, let's say you have 2 variables. One of them is weighted at 70% and the other one is 30%. That means that the final score is going to take the weighted at 70% variable, and it will have more impact in the final score. So the problem with weighted scoring is that this method is easily open to manipulations to achieve the desired results. Now, all these factors combined, and the lack of a solid feature selection process or a structured prioritization method can lead us to something which is called scope creep. While we're discussing and debating and having those meetings, the product feature set grows uncontrollably and it just gets bloated and bloated while we're trying to prioritize things. And because we're unable to prioritize, we're unable to disqualify anything, and the feature set just grows. So obviously we need a better way of doing product feature prioritization. And the way that I developed and I suggest, and with the help of some people on my team, is what's called a Boolean-based algorithmic approach. Now that's some fancy words for something very simple. So let's explain this. Boolean-based means data with only 2 possible values. True, false, yes, no, high, low, 0, 1, 2 options of any kind. So if you're presented with questions that are Boolean-based, that means that the model forces you to make an unequivocal decision. Either you turn left or you turn right. There's no maybe, or let's stay put at the moment. So that's one thing. An algorithm is a set of instructions with a finite number of steps to accomplish a task. So the premise over here, if we're going to apply an algorithmic model to product feature prioritization, is that we're going to be able to consistently and uniformly perform product feature prioritization in a finite number of steps. And this is the Blackblot algorithmic model for product feature prioritization. So the Blackblot model is built on qualifying a product feature using 4 core parameters that could be supplemented with additional parameters if so needed. Let's take a look at these 4 core parameters. So the first one is called dependency, which is the measure of how dependent are other features on the existence of this feature. And again, it's a Boolean, high or low. There is no maybe or medium over here. The second parameter is fundamental. This product will not work properly without this feature from a technical perspective, yes or no. So fundamental means that all the features in the product that are fundamental are like the backbone. You must have them from a technical perspective so that the product can function. Differentiator is a feature that is a key differentiator relative to competing products, yes or no. Now, in the model that we're going to see at the moment, the differentiator parameter is held for reference purposes and possibly future inclusion into the calculation formula. But it's very easy to expand them all. And it's here that the differentiator model is included just to demonstrate how easy it is to expand the model. So the last fourth parameter is called importance. And this is product manager's subjective measure of importance of this feature from any perspective, from product planning, product marketing, product management. It's we believe this is important, yes or no, high or low. So this is essentially a table that contains our decisions. What we did over here is we assigned values to each product feature according to the 4 core parameters. This is data. Now everything is calculated automatically for us. So there's an interim support variable that is calculated automatically as high for all the features which are fundamental, which means that they got to be in the product for the product to function from a technical perspective, or that you got to have them high dependency because other features rely on the existence of this feature. Okay, so this is the interim variable, which is called urgency. Now we have the final priority variable, the prioritization level, which is calculated automatically for importance and urgency combination. So we know what urgency is. Importance is our subjective assessment of if this feature should be included or not, if it's a high importance or low importance. And here are the prioritizations. P1 is the most highly prioritized, P4 is the low priority. And you can see here how the combinations are structured. High importance and high urgency will earn it a P1, that is high priority. So at this stage, we have a prioritized product feature set. And let me recap this. After we complete attribution of values to the 4 core parameters for each feature, the feature matrix is essentially ready and presents a list of prioritized features. And at this point, we can start grouping the features to create distinct versions or roadmaps, whatever we want. Now, this table itself is essentially simplified. It's an oversimplification. Let's look at the complete table with all the various options because there's a lot more over there that can be done. So what I'm going to do now is I'm going to stop the PowerPoint. I'm going to transition to different types of screen sharing, and I will load the Excel file, which is the feature matrix. Okay, so let's take a look over here. This is the feature matrix, and what we see over here are tabs. And at the bottom here, there's the left tab, which is just the title. There are settings, which are the different variables and the different labels that they have. And this is just better programming, so you can change the labels or add, or do whatever you want over here. And so there's some instructions here in the background which show the different combinations which create the different priority levels and some explanations. So let's go ahead and take a look at the feature matrix. Here we have the 3 features of that Nike shoe, just for reference. These 2 columns are descriptive columns, which at the moment are not used in the calculations, but they're there for any debates, or perhaps if you want to, you can later include them in the formula. Or OSRC, outsourceable, means that this feature can be handed out to contract development, yes, no, or in-house contractor. And T-risk is the level of technical risk associated with developing this feature. These are for discussions and debates, but we can add them into the formula. Now, here are the 4 core parameters: dependency, how dependent are the features on this feature; fundamental, the product will not work properly without this feature from a technical perspective; differentiator, and importance is our subjective measure of importance of this feature. Once we complete all of these blue 4 core parameters, urgency is calculated automatically as high for all features which are fundamental or have a high dependency. And the prioritization is also calculated automatically. So that was rather quick. Now, sometimes what happens is that you need to override the prioritization level that was calculated automatically because an exec says we want this feature in, or a customer pays you money in order to include this feature. So you can come over here and select an override. Now, the system is built in such a way that you can only promote a feature, which means if a feature was calculated automatically to have a low priority, you can elevate it and you can raise it to a higher priority. But if the system calculated a high priority, you cannot demote it. You cannot lower that prioritization. Now, obviously, this is my view of things, and that's how the system was built. So in any case, what we have over here is a column called in this version. And these are the features that we're going to start working on. And at the moment, you can see that the formula over here selects the following features: everything that is P1, anything that is P2 and fundamental, or the override is P1. So now we have a list of features here that we can start working on. We can decide if it's a version, we can decide that this is the priorities that we're going to follow, and so forth. This is really a wish list in a sense. And we have not considered things such as the cost and duration of developing a feature. Some features take more time to develop and some features take more money to develop. And you need to balance that out. So what we have over here is two more parameters to consider: the cost, estimated relative cost to develop this feature, high or low, and duration, the estimated relative time required to develop this feature, high and low. And through combinations of cost and duration, we have four combinations, we can reprioritize the original, let's call it wish list, subject to and considering the cost and duration of those features. So now we have a reprioritized list, and we can also do an override over that one. And you get, in this version, a list of features which are essentially our wish list and have been reconsidered according to the cost and duration. Now, all the formulas are open and everything can be changed, but this is the basic idea behind the feature matrix. There's a lot of more things that can be done over here. You can extract some statistics, how many features in this version are differentiators, how much are P1s and P2s, how much are fundamentals, how much, whatever you want. There's a lot of statistics that can be done over here, and that could help in creating versions or in prioritization. So let me close this and revert back to the PowerPoint presentation. So let me continue. We're going to use this product as a metaphor for some products that I've seen actually recently. I'm sure that you've seen software that looks like this. This is the Wenger Giant Swiss Army knife. It's actually been discontinued now. It weighs 1.5 kilos. It's got 130 different types of implements. It's really a novelty in this particular sense. It comes in this black wood box. There's unboxing videos on YouTube of people using this and opening it. This used to cost $1,500. Now that it's been discontinued, I think I saw on eBay somebody selling it for $8,000. So that's a good investment if you have one of these. There are three types of scenarios that cause software or other products to have so many features like this. The first one is called technology-driven. And in a technology-driven scenario, the engineers are in control of the feature set. They believe that more features will add more value. So they just add more features and add more budget and ask for more time and postpone the release date. That often happens in certain technology-driven companies. Another scenario is that we just don't know how to do prioritization. Everything is important, or we constantly argue and bicker about who's going to do the prioritization and what prioritization criteria. And while we're talking, the feature set just grows and everything is important. Another reason that we have these kind of products is something called feature poker. Now, poker is an American card game. Often you see it in Wild West movies, and one guy says, "I will match your $5 and I'll raise you two," and then the other guy matches and raises. Feature poker is when we release a product into the market, the competition copies our feature set and adds more features. Then we copy their feature set and add more features. And this is how through several cycles, we get these products. You see, really what the customers want is a product with an optimized, prioritized feature set, exactly what is needed for the right user and the right task. So let's conclude now with the summary. I think some people think that product feature prioritization can be a daunting and exhausting task, and some people don't like it because of the endless meetings and the ambiguity. But with the right tool, such as an algorithmic model, this or anything else that you can come up with, this critical activity can be accomplished far more easily and faster than ever before. So if anybody wants to communicate after this session and send questions or comments, then you can do it through the Blackblot website, or you can reach me on LinkedIn. And at this point, I want to thank Scott Baldwin for inviting me over. I want to thank you all for listening in to this presentation. I hope you've gained some new insights and new ways of thinking about product feature prioritization. And I hope it will help you in your career and doing your work. So at this stage, I think we're into the Q&A. I will stop the sharing now. And if anybody has any questions, I'll be happy to answer them.
So one question I think a few people have had is, can we get this? Basically, can we get this spreadsheet? Where do we find this framework? Can we download this thing?
This is part of the toolkit, but if anybody wants to, I can show it to them in a Zoom session or whatever. The toolkit is a commercial product that we have. It's a certification, the book, and everything else is handed for free to anybody who participates in our training. So really, if somebody needs to buy it, they can buy it online, but with the whole set of templates and everything. If somebody really wants to, then I'm not going to start asking them to buy everything. I will explain it. And I think it's relatively simple to reverse engineer it. It's just a couple of formula. It's the logic and the way of thinking, which is more important than the actual spreadsheet itself.
Yeah, fair enough. I put a link there in the chat to the methodology page, which I think has the ability to get all of the stuff that you talked about, if I remember correctly, right?
That is correct, yes.
Awesome. So hopefully that'll help some of the folks that asked about that. Jumping into another one here. Why is important an input variable? Doesn't allow the PM essentially to skew the results, which is contradictory to the whole point maybe of an algorithm on that side?
Yes. I was expecting somebody to say that. The thing is that there's a lot of considerations which are subjective, and we had to create some kind of a catch-all variable that would encompass all the different thoughts and ideas and debates and considerations if this particular feature is important or not. This is a counterbalance to a very dogmatic and very mathematical approach to prioritization. But the model itself can be expanded and it can be contracted as well. It's very easy to change importance in anything else that you want. So we thought it would be important to include something that would provide more of an opinion, intuition, or something like that. But we couldn't start parsing it into millions of things. So we did just one catch-all.
How's the second priority calculated?
There was an interim variable and a final variable. And the final variable is calculated according to the combinations of urgency and importance. So when you have the two parameters, you have four different options: high, low, high, and those kind of things. You can complicate things by adding more variables and creating more combinations. It becomes a game of combinations, but I like to keep things simple. So I think up to 4 parameters should be enough. Now, if you disagree, if one disagrees or has better parameters, then what they can do is they should substitute it. But I think more than 4 parameters, you're getting into too many combinations.
Yeah. And is there a priority kind of after the cost and duration side of that thing, or how do those factors, like parameters, kind of factor into this?
Do you mean how we calculate the priority according to cost and duration?
That's correct.
So it's a little bit arbitrary. What we said, if something is high cost and high duration, then it should get a low priority. Things that are cheaper to do and things which take less time to do than something that takes a lot of money and a lot of time and will monopolize the entire development effort. So you can take it from there. Something that's low priority, something that's low cost and low duration will get a high priority as to something that has a high duration and high cost. But again, the whole idea with the algorithm was to bring closure, to bring some finality to product prioritization. Because I have been, and I don't know if the participants have been in sessions where there's just endless chatter and debate and you get nowhere and you need to move forward. So it really doesn't matter if feature number one or feature number two is going to be done one day or 1 week before the other one. We need to bring closure and move on. We're constantly overworked at some of these jobs. And I created this as a necessity and as a response to a lot of my work experience and the experience I had in consulting and training over the years.
Is this a collaborative exercise? Is it an exercise maybe the PM goes through first to table a model that they see in terms of their thoughts on this, and then it's brought to more of a collaborative? What I'm trying to get at here is I think people have different ways in which they work, either organizationally or cross-functionally, to make these decisions. Sometimes that's empowered PMs that have that decision-making capability. In other cases, it's a bit more consensus-based, as you've probably seen. Just be curious on how you balance that and best to use this methodology.
Okay, so we need to revert a little bit to the roles in PMTK and how decision is made in PMTK. There are two things that cause people to have a lot of meetings. It's sharing information and trying to gain a consensus or agreement over certain decisions. And you can eliminate that by finding a way to share information more efficiently and getting some kind of a mechanism that drives decision that is not based on consensus. So the whole idea over here is that you have along the line of a product life cycle, product development cycle, whatever you want to call it, there are different people who own different sets of decisions. And everybody else during that time is decision support. So for example, over here, in this particular case, the product manager is the one making the decisions. And everybody from development and sales and program management and executives is supposedly decision support. And the idea is that you listen as a product manager to everybody, you factor all the considerations in, and then you make a decision, a right turn or a left turn, a high or a low. Now, this is called something like a prioritization committee or whatever you want to call it. But there's only one individual making the decision, and that's the product manager. And sometimes people decide that they don't like the result and they want to override it. So the only way to override it is to go to the executives or to the program manager who is managing the entire product development program and seek guidance over there. But the only person that can override in the PMTK models in prioritization is an executive. And it's usually the chief product officer, VP of product, or something like that.
How do you essentially prevent every roadmap item getting a fundamental and high urgency kind of setting?
I'm not sure I understand that. You mean somebody's going to come and say everything is important and everything is high urgency and everything is fundamental? The system is not foolproof. There's always going to be a fool that's going to prove the system is not foolproof. There's a joke. The thing is that you want people to be as objective as possible. And I think that the algorithm at some point makes you realize that there's things which are important and less important, things which are urgent and not urgent. The whole idea is to try to be as objective as possible. If somebody wants to, I'm not going to call it abuse, but if somebody wants to play the system, they don't even have to do that. They don't have to select fundamental high urgency. They can go into the formulas and change things and everything is going to go according to how they want. But if you're looking at things objectively, then attributing values to the four core parameters to each feature, if you do it honestly and objectively, you will get better results than just having a meeting where everybody argues. This is in my opinion and my experience, and I've been in this business for 20 years and I know what's right. And it's just a more objective way of bringing finality and closure.
And if anything, to your point earlier, maybe expediting what is essentially a pretty messy process today.
Oh, I see here. How is the differentiator parameter being used? It's just like any other parameters. You can either substitute it for something else. So, for example, you can decide that the importance parameter, which is the subjective level of importance product manager has, is not important, and you can substitute the differentiator instead of that, or you can add it and create more combinations, and then you decide which combinations have a P1 and which combinations have a P2. It's really a game of logic and things like that. But the thing is that people need to understand that product management is part of social sciences. It is not an exact science. It's not engineering. It's not mathematics. It's a managerial approach. It is not anything that has to do with the laws of the universe and physics and math and things like that. And nothing that you've seen or hear comes from God or from some kind of an established research that's been done and proven. This is an approach. So the thing is that you need to qualify this approach and other approaches if it appeals to your common sense, if it appeals to your objectivity. And if it does, then that's what you need to use. But the extreme side of the spectrum, which I alluded to in a very brief way, is those unstructured debates, which are the most common way that people do prioritizations. And I'm just going to add one more note about that. In some of the instances that I've been to or have participated in, it was something like a Turkish bazaar where you haggle over things, or it was something like in the Wild West horse trading. You check it and you will make an offer and they give you a cover, and you walk away and they say, come back, I'll give you 2 features for the price of 1, things like that. That is too unscientific and that is too unprofessional in my mind as a way to do prioritization.
Yeah, there's just too much at risk essentially at that stage.
Anything that's more objective than having smart people with big egos trying to prioritize features is going to be better.
Maybe one other question, some people view prioritization as maybe a mix of, I'll call it art and science. And there's obviously an objective set of criteria here. You're trying to filter out some of that subjectivity. How do you use this to balance maybe people with the perspective you're maybe tilted a bit more towards the art or a bit more towards the science?
The feature matrix is a reflection of my view of product management. It is an outcome of my way of thinking of product management. And my way of thinking about product management is that it needs to have some kind of internal guidance, some kind of fundamental principles, some kind of way of how you deal with tasks and you approach different tasks. And the whole discipline has to be guided with ideas or concepts that instill governance. Now, that's a lot of fancy words for just saying there needs to be some principles to product management and how you work in product management. So what I try to do is everything to have some kind of a structure, follow some kind of logic, something that's a best practice. Rather than reinvent the wheel every time, every activity has already some kind of a method to it. And you need to focus on following the method, flawed or not, and think about the decisions that you have to make at each stage. The decisions you make are far more critical and influential than the actual process that you're taking in order to reach something. Now, if somebody could have a debate where they would talk about which features are fundamental and which ones are differentiators and which ones are I don't know, urgent or whatever, then you would have a much better debate. But people don't do that. They're sometimes emotionally attached to a feature which they advocate, and that creates a skewed discussion, and that prolongs the entire process and creates the bickering and everything. The feature matrix is a reflection of how I see things. It's more important to think about the decisions at each phase and stage than to look at it as some kind of a touchy-feely art forms thing.
Yeah. Okay, that's great. And I think really important here to reflect too is you've shown us one part of an overall toolkit. So really important too that people take that in the context of the larger toolkit, which has a lot of detail and a lot of definition, a lot more insight as well in terms of how to operate an effective team and execute properly overall.
Exactly.
Thank you very much, Gabriel. I don't think we have any further questions today, so I think I'll wrap stuff up. Just shared a link in the chat for our post-event survey. We'd love to get your feedback. If you have a moment to share that, we do use that feedback and provide it to our speakers, but it's also very helpful for us in running our event, and you could win one of our potential monthly prizes as well. If you want to continue the conversation on this, feel free to post a topic within our community. We'd be happy to have further discussion or conversation on this. We have a number of different community events coming up. Next week, we're talking with Timothy Kreschel. We have our mini conference coming up at the end of the month, and a number of different events running all the way through to October at this point in time. Speaking of our Supercharge Your Product Team mini conference, we have 12 amazing speakers participating. And if you do want to speak or you have something to share from your product practice, we'd love to hear from you. You can find out more about how to become a speaker here at Product Makers by searching for Speak within our community. And we'd love to hear from you, the makers, the people building products, how you're doing it, how you're approaching it, and have you talk a little bit about your craft. So feel free to get in touch with us on that side. And with that, thanks very much for joining us. And thank you, Gabriel, for everything. Really appreciate it. We look forward to seeing you all soon. Thanks again.
Thank you very much. Goodbye.
Bye.